Okay, so everyone should be able to make a graph, should be. If not, look at your graph. If you say, I cannot make this sine graph, please use this opportunity to brush it up. Next Friday is our test 2. It's progressive, meaning that you're going to make the sine graph and, well, you don't make sine graph and cosine graph, but you have to make secant graph and cosecant graph. If you don't know how to make a sine graph or cosine graph, then the question is, how on earth are you going to make these secant graph and cosecant graph? Okay, so I have a -2 pi. This is pi, and 2 pi right here, and then pi. I'm gonna be lazy a little bit here, not drawing these middle points right here. So copy as well. So I'm gonna make some points to draw my dots. Sine x starts from the origin. The period is 2 pi, so that means 2 pi units away, there should be another point at the same location. And if you remember that it goes up and then down, so it will go up and then get back to the midline again, and then it goes down. So you have this, right? So you can draw this part of the graph pretty easily. Okay, and then the same goes to the left-hand side. So it goes down to the left of the y-axis, and then it goes back up. So now here's another thing. So disclaimer, if you are going to calculus, you have to know how to make the sine graph and cosine graph at any time. If I wake you up in the middle of the night, I say, all right, go ahead, draw me a sine graph and cosine graph. You have to be able to produce these two graphs with great accuracy. Okay, and cosine graph would be very straightforward, right here. And then it starts from 1, period's 2 pi. So I hope that you're proud of your own self, that you have the skill to draw these graphs. Okay, it's not a guarantee, by the way. I hope that you are showing yourself that you have acquired all these skills. Okay, so I put it under the topic of, here are the things that you have learned. Fair? I think you have learned these last semester. And by the way, your unit circle stuff, values, like the graphs should act as a reinforcement of those unit circle values. Okay, such as, this is quadrant 1, this is quadrant 2, so they are positive for sine. For quadrant 3 and quadrant 4, the values are negative. All right, for cosine, well, quadrants 1 positive, quadrants 2 and 3 negative, and quadrants 4 positive. And of course, last few days we talked about the inverse trig functions. Inverse trig functions, we talk about 1-to-1, so you know how we restrict them. Okay, now let's talk about some early school year stuff. Let's look at sine graph first. Sine x. If I ask you the question, hey guys, is it an even function or odd function? Even function or odd function? Do you still remember what even function is and odd function? What they are? Anybody who knows vaguely what they could mean? Yeah. Do you remember when we talk about even function and odd function, what graph I asked you to draw to help yourself? X squared is an even function because well, the reflection over the y-axis, but the even, like it's the easy connection that x squared is an even function is because of the power, right? So that's how I want you to make your connections. I understand that even function is not an easy thing to hold in your brain. So I ask you, hey guys, please go ahead and draw x squared. If you know how to draw x squared, which I know you do. If you know how to draw x squared, then you know it's an even function. And what function did I ask you to draw for an odd function? X cubed, right? Now, so you can go ahead and draw a little x cubed function right here to the side, just to illustrate that, hey, this is an odd function because it is it is symmetrical to the origin. So we have this origin symmetry. Okay, it's a reflection over the origin at 0, 0. Well, can you see how sine x is also having this origin symmetry? Okay, so that's why we say sine x, it's an odd function. Okay, sine x is an odd function. Now, there's another notation. I'm not sure if you remember. The notation is this. Do you remember the notation that f of negative x is equal to negative of f of x? Well, on paper, this is how we annotate an odd function. Do you remember this? Feel free to say no if you don't. Maybe. Okay. Now, of course, we want to see how it applies to here. So to apply it here, this is what we say. Well, that means sine of negative x is equal to negative sine x. Sine of negative x is equal to negative sine x. And you might be feeling like, well, sure. But what does it mean, really? What does it mean, really? Well, how about this? What if I give you something like, hey guys, what is sine of negative pi over 2? What's the value of sine of negative pi over 2? Fast. Negative 1, right? And now, what about sine of pi over 2? That's 1, right? So on the left-hand side of the equation, that's negative 1. This is a negative on the right-hand side. And negative of what? 1. So that's how we know it's true, because this is negative 1. And the right-hand side, it's also negative 1. So that's how we know the graph, it's reflected over the origin, meaning that f of negative x right here is the negated version of f of x. That's how we know it's a reflection over the origin. On the other hand, cosine x, well, it's reflected over the y-axis. Okay, so when we learned even function, I asked you all to draw a graph. I say go ahead, draw a quadratic. Okay, that should make a very easy connection between an even function and the quadratic, because the power is even. So that's a reflection over the y-axis. Reflection over the y-axis. Okay, so we have the y-axis symmetry right here. And because of that, it allows us to write something like this. F of negative x is equal to f of x. F of negative x is equal to f of x. Well, to apply it to this case, it means cosine of negative x, it's going to be cosine x. Now, when I was learning this, I was like, wait, hold on. Where does that negative sign go? How come cosine of negative x is equal to cosine x? Where does that negative sign go? Well, and then I find myself inspired by actually thinking of an example. So here's an example for you. So what if I give you this? Cosine of negative pi over 3. What's cosine of negative pi over 3? It is 1/2. Just 1/2. Quadrant 4, it's 1/2. And what about cosine of pi over 3? 1/2. Can you see how the left is equal to the right? So that was something I did not understand when I was learning this. I was too focused on, wait, what? Cosine of negative x is equal to cosine x? Where's the negative? That's strange. Well, because I never had the idea of, oh, what is an even function? Okay. Any questions so far? Yes.
So cosine and sine are both even functions?
No. They look the same, but the reflection is different. Sine x is an odd function because it's reflected over the origin. We judge not based on its look. We judge based on the values. Okay. So are you thinking about the look? They're the same, so they are both even?
Well, I thought this is a negative one equals negative one.
Well, they're equal, but it's sine of negative x. It's equal to negative of sine x. Yeah. The notation is different among those two. Okay. All right. So that's something we learned and we applied here. So make sure you know how to write out all these even function, odd function in terms of the notations. Okay. So even function is f of negative x is equal to just f of x, while the odd function is f of negative x is equal to the negative of f of x. Okay. Now, next up, okay, go ahead and draw a rough unit circle right here. Okay, just maybe the size of your palm. Hope you, well, maybe if you have a big hand, then just half of the size of your palm. Okay, just quickly draw a unit circle. And on this unit circle, I would like you to go ahead and construct a right triangle right here. And let's call this theta. And label this point as x comma y. What's the hypotenuse for this right triangle? What's the hypotenuse of this right triangle? Yeah, and well, that's a simple way to express that. It's just 1. But we'll get to that x squared plus y squared thing in a moment. Okay. Now it's equal to 1 because that's the radius. Okay, when we say a unit circle, the key thing about unit circle is that this circle has a radius of 1. All right, and since it's a right triangle, I think we can write something down here. Would you agree that x? Well, hold on. Would you agree that the length right here, it's called x? Because, well, this is the x coordinate, this is the x value, right? So the length from 0 must be x. Would you agree that this distance right here, it's y? Because that's how many units away from the origin, so it's y. So what's going on here is this. So if you look at this right triangle, and based on what you learned back in geometry, or even earlier than geometry, we can write something like this, right? X squared plus y squared is equal to 1. That's geometry stuff, right? Are we good? What's the PreCal stuff? Well, the PreCal stuff tells us that x is equal to cosine theta, right? And y is equal to sine theta. Well, how can we merge these two things together? Now, we are on to a new topic today. And before I officially introduce you this new topic, well, I have a couple of things to do. First is this part, which is to introduce to you that, hey, guys, you have learned quite a few things already, either this year or even earlier than this year. And this new topic, it's actually nothing really new in terms of the materials, the concept, yes, the process, yes, but the stuff that we're using is some old stuff. So I want you to know where these old stuff are coming from. That's number one. Number two, this topic called trig identities. This is my favorite topic for two reasons. One is that I would say this is the very first topic in this course that you are going to have a taste to see, to experience how you will think as a calculus student. It's not hard. I will teach you how to think. I will let you practice how to think, but I need you to know that you have to adapt this new thought process. You cannot just follow procedures and do things. It's not going to work. Okay? Gotta learn how to think. The second reason is that when you start thinking about all these possibilities, you may actually utilize this thought process in life, in your life planning. And I will dive into this a little bit more later on. Okay? So how can we merge things together? Well, we can create things together. So we say, well, x squared plus y squared is equal to 1. Well, x is what? X is cosine theta, and y is sine theta. So that means we can write this as cosine squared theta plus sine squared theta, it's equal to 1. And this would be your first identity, and it's going to be a very useful identity for the upcoming days and weeks. Okay? So I don't want to just dump you some identities and say, memorize them. I need you to know where they came from. If you don't know where they came from, well, the problem is you are going to lose them. They are not meaningful to you. But once you know that, oh yeah, cosine squared plus sine squared equals to 1, I know where they came from. It comes from the unit circle. It's draw a triangle, x squared plus y squared is equal to 1. It's the same thing. Okay. Now we will talk about this another time, okay, in the future, and we'll dive in, like this will be another entry place for another topic, but it's an important one. Okay. And by the way, you are more than welcome to swap things around. You can say 1 minus cosine squared theta, it's equal to sine squared theta. Feel free. But that's the bare bone, simpler stuff. Okay. All right, now, other things that you have learned. Well, what's cosecant x? One over sine, right? So let's go ahead, write this down. So cosecant x, it's 1 over sine x. And then we can ask the question, hey, what is secant x? 1 over cosine x. And we can ask the question, what about tangent x? Sine x over cosine x. What about cotangent? Inverse of, well, not inverse. I mean the 1 over tangent, reciprocal. 1 over tangent x, or cosine x over sine x. Well, inverse. The other one for tangent x, we can also say tangent x is equal to 1 over cotangent x. So you can see a lot of variety stuff here. Okay, so make sure you kind of recapture them. Something that you have learned already. Make sure you can see them, show them to everybody. So far, so good. If so far it's so good, then I'm going to ask you to do the following. How many ways you can express sine x? And how many ways you can express cosine x? So I'm going to give you a minute to think about this question. You can discuss with your partners, classmates around you. All right, so how many ways you can write down sine x and cosine x? There should be at least 3. All right, how many ways can you express sine x? Suggestions? Okay, that's a good one. Tangent x, cosine x would be a good one. Anyone else? Yes? 1. Now you may say 1 minus cosine square x with a square root on top. You may say it that way. 1 over cosine x? No. 1 over cosecant x, yes. 1 over cosecant x would be a good one. I think that's, is there one more? Huh? One over what again? You said tangent x times cosecant x? Or cosine x? That would give you 1 over sine x. You can say cosine x divided by cotangent x. That would be a good one. Okay, so you have all these possibilities. And cosine x would be taking a very similar turn. Cosine x could be, suggestions? Square root of 1 minus sine square x. Okay, what else? One over secant would be a good one. What else? Which one? Tangent times sine. Nope. Because tangent x is equal to sine x over cosine x. So if you want to solve for cosine x, it becomes sine x over tangent x. You can do sine x times cotangent x, that's for sure, yes. So when you write down all these possibilities, I hope you can see how you get these possibilities. I do not want you to just write down these possibilities. You've got to think. Copying, it's of no value. Make sure you are thinking. And this is the main idea on this topic. Trig identity is a topic that requires you to think of possibilities. Okay, possibilities. And then you decide which route to take. So there are two questions that you keep in mind. The first question is, what could you do? Okay, what could you do? And then, based on all the possibilities, then you decide, what should you do? It's a little bit philosophical here. It's a way to think. Okay. All right. So yeah, put a little check mark next to the things that you knew, if you're comfortable. Okay. So this is a little reference sheet. Okay, for you. All righty. So let's take a look. I think the reciprocal identities are pretty good, right? We have talked about them. You should be comfortable with them. The ratio identities, I mean, the name doesn't really matter, by the way. The name, like whatever these names of identities, they don't really matter. It's just the core, the content matters the most. The Pythagorean identities, the first one should be good. Wait, hold on. Where did they get the second one? How did they get 1 plus tangent square is equal to secant square theta? Now, I'm going to tell you the truth. There are two truths here. First, you need to know them all. And two, I don't know the second one and the third one by heart. Because they're harder to remember. So instead of memorizing it, which is prone to errors, what I did is this. I want you to write this down too. Okay, on the side, on the blank space to the right, don't waste them. So I want you to go ahead and write this. Cosine square theta plus sine square theta equals to 1. So how can I not memorize them and I am able to know them every single time? Well, you just need to ask the question. Where did they come from? Simpler than that. I mean, well, this one, yes, but I mean the second one, 1 plus tangent square equals to secant square theta. The second one, this one. Like how on earth we got tangent and secant square into the scene? More than that, but simpler. What happens if we just go ahead and divide both sides by cosine square theta? Well, we can tell you the right-hand side. The right-hand side becomes secant square theta. What about the left? Well, you have a common denominator for both terms in the numerator, so that means you can split them. So you have a cosine square theta over cosine square theta plus sine square theta over cosine square theta. Well, what's cosine square theta over cosine square theta? That's 1. What's sine square theta over cosine square theta? Tangent square theta. And can you now see how the second identity comes into place? If you know the first one, just process it. Divide both sides by cosine square theta, you've got it. So that's how I do not memorize these two, but I generate them every single time if I need to use them. My memory space is very limited and precious. If I can generate something, I generate them. And I don't use them often, so they're good. So now my question is, how do we get the third identity? Can you guess how we get the third identity? So you have the original, but you divide it by sine square theta. Don't forget to say the square. So once you divide both sides by sine square theta, then on the left you will have, well, cosine square theta over sine square theta plus sine square theta over sine square theta. And on the right you have 1 over sine square theta, meaning that it is cosecant square theta. And by the way, I want to make sure that my square it's looking like a square more than just a coefficient 2. Okay. And then cosine square theta over sine square theta, it's equal to cotangent square theta. And then sine square theta over sine square theta, it's equal to 1. Can you see how the third identity comes to life? So there are things that you should memorize. There are things that you should just make them. Okay. This one, I would say, just make them. Okay, just make them. And then for the bottom ones, odd and even function, we talked about this at the beginning. Again, I would not suggest you to memorize all these. Instead, I would say make sure you know even function is f of negative x is equal to f of x. And then f of negative x is equal to negative of f of x for odd function. And you should be able to generate these identities based on your familiarity of the graphs. If you know the graphs, then you're good. If you don't know the graphs, then now is the time to know them. Okay, don't procrastinate. So now, what are we doing with all these identities? So we are going to do a couple of things. Today's the introduction. Tomorrow we'll work on the more simplifying, and then on Monday we will talk about verifying. So we'll have some taste of those today as well. So now I want you to label something right here. If you look at the first example, so it's asking you, well, can you simplify this? Like this is the question itself. This part is the question. This is just a work. Now, I want you to label something though. I want you to draw a little box. Okay, with dotted line. And the reason I want you to box this area is because I want you to acknowledge that you will do this mentally. This is mental math first. What does it mean? What does it mean? It means that before you even pick up your pencil and put a dot on the paper, you got to think about this. You have to think about this in your head. So you're asking yourself a question. Secant x. What could you write as a secant x? I'd be like, 1 over cosine, maybe? Okay, so you hold that idea. So 1 over cosine in your head. And you think about, what about cotangent x? And you're like, what's cotangent x? Cosine x over sine x, maybe? And then you realize something could happen. What could happen? You cancel out. Then you start writing stuff down, because now you can see the light at the end of the tunnel. But before you see that outcome, do not write anything, because it's not going to be fruitful. If you start writing without knowing what's going to happen, because you may embark onto a totally inconvenient direction. So you need to see directions before you start walking. That's my point. All right, now here's another tip. Now, it may not work for all situations, but it's a tip that you can consider. Think in terms of sine x and cosine x. Think in terms of sine x and cosine x. So let's think about this. All right. So we have cosecant. Oh no, sorry. Cosine square theta. Well, that's cosine square theta. And then you have secant theta and cosecant theta. So you start thinking about Well, we have cosine square here already. Well, what can secant theta be? What can secant theta be? 1 over cosine, right? Now, I'm going to write this so that you can see your mental math more vividly, but you're not writing it down yet. So this is your mental math. So like, oh, I can see this is 1 over cosine. What about this? What's cosecant theta? 1 over sine. So you're like, oh, what is this? What's going on here? You're like, oh, wait, hold on. I can see something that can be canceled out. Wait, hold on. I see something right here. Do you see something right here? Cosine being the numerator and sine being the denominator? That would be cotangent x. And that is the answer. Or cotangent theta. And now you start writing things down. Because you see the, well, finished problem. Not only you see the end of the tunnel, you actually finish the problem. So that's why I ask you to think about what you could do first, prior to deciding what you should do, prior to you writing down anything on your paper. Okay? You've got to write, you got to think before you write. Okay? Let's try one more. Okay, now next one is simply asking you, can you show how the left-hand side it's equal to 1? Okay, so you think about so it's just 1, huh? It's just 1. Well, cotangent is what? Cosine over sine. Now I'm going to write this down for you to see your mental math more vividly, but you're not writing it down. So you're thinking about, oh, this is cotangent. Cotangent is cosine theta over sine theta. You can hold it in your mind. And then secant theta is 1 over cosine theta. Still hold it in your mind. And then you have sine theta. So you're holding everything in your head. And you're like, wait, hold on. Can you see something? You can cancel them out. And they are canceling out each other so perfectly that it would end up to be just 1. And like, hey, that's easy, right? Now, and this is the time that we say, well, you don't think of other possible, well, you can think of other possibilities, but you don't entertain them. Okay? You don't entertain them. Like we talk about how you can express sine theta, right? But most of the times we'll just keep it at sine theta and cosine theta to process our math. Yes. Well, we're just trying to show how the left is equal to the right. So that's what we're showing. Yeah. All right now. So tomorrow we'll come back and finish this. But you can try to take a look at this. And it's going to be pretty fun to do.